Alrighty. Thanks everybody for coming to this talk. Really appreciate you guys coming out of Bitcoin Plus Plus from wherever you are. My name is Tristan Bietsch. I'm the founder and CEO of BitEscrow. And today we're talking about how BitEscrow is pioneering non-custodial and reversible transactions at a layer of security for Bitcoin payments. So today's key topics are just 5 simple topics. So the first one is, what is BitEscrow, right? We're going into depth of what we do and how we do it. An announcement of what we built for you guys, a live demo of said announcement, and then a technical deep dive from my co-founder and CTO, Topher. And after that, a Q&A from the audience. So without further ado, let's get started. So for those of you who don't know, escrow simply means buyer protection. It's super simple and straightforward in how it works. The buyer and seller agree to terms of a contract. The buyer submits payment to the agent. The seller then delivers goods to the buyer, and once the buyer approves of the goods, they release the funds to the seller, right? It should be a super simple and straightforward process. And everybody uses escrow every single day, whether you realize it or not, because it's actually the hidden pillar of the financial world. If you use Amazon, you use escrow. If you use it as a credit card, you use escrow every single day, because how a credit card works is once you submit your payment to, let's say, the merchant, that money is held in escrow by the bank until XYZ happens. And then after the release of the funds happens after like, I don't know, 2 weeks to a month, then it goes to the merchant. And this is used for disputing transactions, right, in the fiat world. But there's a lot of problems with modern escrow. And I mean, escrow is great. It's a very important pillar of how we use the financial world today. But it hasn't been updated since the 90s, right? And before that, 1880. I'm not joking. It really needs an update. So the main problems of the modern escrow world is that, first off, it's fully custodial. And this requires absolute full trust of the agent and or platform that you're using. The next one is that it's super slow, right? So it works as fast as banks are when they are open. So if you want to do an escrow transaction on Sunday, good luck. And like I said, there are banks required in every step of this process, and who trusts banks nowadays? Very limited reach, so it's very difficult to do business between countries, or if there are multiple countries involved in transaction. So if I have a user from, let's say, India, and another in America, there's a lot of paperwork involved to get that transaction done. High fees. So these are ridiculous and absolutely unnecessary, from wire fees to credit card fees. The list goes on. Zero auditability. So there is no way to audit a transaction, verify anything and everything that's going on in negotiation or settlement for a fiat escrow transaction. And this has a lot of security risks. And again, you have to fully rely on the company when doing this transaction, which invites in fraud. This goes hand in hand with security risks, and people have a high chance of funds being swiped away by an agent. And I've seen it before. So if you go to, I'm not going to name names, the review page of certain companies out there that do fiat escrow for people, there are reviews of people losing $20,000 or more in a transaction just because they couldn't contact support or have their bank open up the account. It's just a mess. The last one is that it requires full KYC, right? And this makes escrow way less accessible and way more formal than it has to be. And the list goes on and on and on, because I go on about this all day. But it's crazy, because where is the innovation, right? Since the 90s, nothing has changed in this entire process. Bitcoin has transformed every single sector of finance. For example, we have Robinhood to Coinbase, PayPal to Strike Wallet. We have point of sale from Clover to Ibex. But for escrow, there is nothing. The hidden pillar of finance of the world, zero innovation since the 90s. And it's a real issue, because it's in our face as well, because Satoshi wanted us to improve escrow. So Satoshi was aware of this problem, and he knew how important and how pivotal escrow is for finance, because on the first page of the white paper, it is glaringly obvious. He said escrow needs to be built to protect buyers, right? See the red arrow in the highlight? It's right there. Yet nobody has succeeded in building a proper escrow system that utilizes Bitcoin until now. BitEscrow is the innovation. So we are the new standard for the entire escrow industry, and we have completely reinvented how escrow works. So what are we building to fix this issue, right? We're building three main things. The first one is an application for grandma, right? Because right now, all the apps that use Escrow are not that great, and our app that we built is built on top of our API. So we have an API for the developers. It's open source and on our GitHub, and we want developers to build really awesome stuff using this. And lastly, we have a full suite of SDKs, which include libraries, a testing suite, and so on. All right, this is great and all, right? Boring. Why is Escrow a big deal? And why is what we're building a big deal? So this is a big deal for three main reasons. And the first one being is that we're bringing Bitcoin native, non-custodial smart contracts that are way easier to use and program for Bitcoin developers, which also ties into smart collateral, right? Similar to the contracts, this will allow programmable collateral that can be used for loans or anything else. But ultimately, for the first time in Bitcoin's history, this will bring about refundable and disputable transactions. And this will bring about the ability to, much like a credit card, dispute and essentially reverse a transaction, much like you would with a credit card. So some features of what we're building, right? The first one is that it's super fast. At the speed of Bitcoin, it's 109 times faster than fiat escrow. Let me say that again, 190 times faster. We have incredibly low fees, right? So we are fifth the price of, on average, compared to the fiat escrow world, because there's just no need to charge high or exorbitant fees. And because we use Bitcoin natively, there's zero banks involved in the process, right? Unless you are using a third party that opts in to use our API with a bank, there are no banks involved from start to finish. Unlimited reach, right? So since Bitcoin has no borders, neither does our company. It is non-custodial by default. So we use a 2 of 2 MUSIG, multi-sig system, and this is just really good for security. Another thing is that it's fully audible, so any transaction that you make with Alice or Bob is fully audible cryptographically with the agent as well as the buyer and seller. It secures your privacy by default. So by default, we collect no metadata unless you give it to us, and when it hits the blockchain, it's a whisper. Whether you have 10 or 100 people in a transaction, when it hits the blockchain, it's very private. No KYC. Because there's no MTL laws around what we do not need, nor do we want to, do KYC with what we are building. And the best part, that you can use this today. This is not just an idea. This isn't just a white paper. This is real, and you can use it today. And the things that you can use today are three things. So the first one is our API and SDKs. So it's available on our GitHub, and we have full documentation on how to use it. And our SDKs include a test suite that works natively with Bitcoin Core and made in TypeScript. But we are really excited to announce our biggest milestone so far at BitEscrow, and that's our developer playgrounds, which will be a huge deal. Interact with our API like a GUI. So the playground works on all test chains, Mutiny, Testnet, Signet, and RegTest. And on the GUI, there's also a JSON view. For anything you edit in an input, you'll be shown a JSON view option for that as well. It's fully open source, so if you go to GitHub/BitEscrow, the escrow repo is there. We're still working on this. A full tutorial video series on how to use it is coming soon. But this series will include how to use it start to end and do a lot of custom things with our playground. Last thing is that there is a Discord community full of developers like you can talk to and work with and building whatever you want. So, with that said, we will now dive into a live demo of the playground. And I would love to introduce my co-founder and CTO, who's been nothing great, Christopher Scott.
So, let's start with the demo. Playground.bitescrow.app. Boom. So this is the playground. So yeah, you can look at this yourself on playground.bitescrow.app. I have a couple confessions to make. One is I did not prepare for this talk absolutely whatsoever. I've been squashing bugs the entire time. Also, while I explain this, there's unfortunately some terms that I'm going to have to try and avoid because I don't want to get arrested today. And apparently saying the wrong thing about your company will get you arrested these days. So yeah, we're We're a contract service provider. Let's put it that way. And this is our app. It's a developer tool. It's used for us, but it's also used for you guys to play around with our API and see what we can do. So yeah, we have some cool links on the front page here. You can see our documentation here with examples. The documentation here is a little out of date. We've been making some changes to our API based upon feedback from other companies that we've been working with for partnerships. So after this presentation and a few days of rest, we'll have the API documentation updated. But just for now, some things might be a little out of date. But yeah, so let's go ahead and get started. We're going to run through this real quick, and then I'm going to dive into my slideshow presentation to go over the technicals. So let's say you want to start a contract with somebody, anybody for any particular reason. So in our protocol, there's 3 phases. There's the negotiation phase, there's the funding phase, and then there's the settlement phase. And as far as our protocol is concerned, we're completely blind to the negotiation. We don't participate in negotiation whatsoever, and we don't make any rules upon how the negotiation between members of a contract has to go. But we have some ideas. So we've been experimenting with different ideas. One idea we had was doing peer-to-peer collaboration over Nostr. I actually built a whole Nostr SDK just for doing encrypted rooms over Nostr with shared state between parties, so you can sort of do this peer-to-peer without having to run your own backend. But it sort of just became too much code to deal with. So it's something that we plan to release in the future, but for now I kind of wanted to start off with something a little more simple. So that's what we're going to do today. We're kind of going to go through this, how do we do this like really low-tech peer-to-peer collaboration of a contract. So on our playground, you just go ahead and click New Contract, and what you'll be presented with is a form. And what this form is it's basically collecting all the information that's going to go into what we call a proposal. The proposal is essentially the precursor to a contract that we would receive. You can think of it as a PSBT. It's a really fancy PSBT that can do a lot more things that a PSBT can normally do. So all of this fancy form stuff that you see, like Tristan mentioned earlier, it's really just a JSON file. So as we fill in this contract, you'll see this JSON change. But essentially, this JSON is the proposal. And this is what you're negotiating with other parties of the contract. So we have some simple templates that you can start out with. And to be honest with you, some of these are broken. There's some bugs that we still need to hunt down. But for this demo, I'm going to do a simple buyer-seller arrangement with third-party arbitration. So I'm going to go ahead and select that. And we're still kind of experimenting with like what is the best way to negotiate a contract that involves public keys and even Bitcoin addresses. So typically you have this PSBT format and you have a signing device that speaks this language. And so you would present this PSBT to your signing device, and hopefully your signing device knows what this PSBT is trying to express. Maybe it does, maybe it doesn't, but hopefully it does so that you're not blindly signing your money into this PSBT. But yeah, so you would essentially, your signing device would interact with this PSBT, add signatures, and that's how you would collaborate on a transaction. So we had to basically do something similar, but from scratch. So what we did is we built our own signing device. And this is open source. It's sort of a new paradigm. It's designed to run in the browser. It's actually designed for insecure environments, and I'll kind of go into like how we reason about that. So in the playground, you'll see this little key in the bottom right corner. So this is the signing device. And right now, I've already set up like 3 different signing sessions that I'm going to be using for this presentation. But essentially, if you wanted to create a signing device, all it is a key pair. You have all the standards that you would expect. You can create one with a seed phrase using BIP39, or you can import. We have various options for doing imports. Whether you create or you import a key pair, you'll always be asked to put in a password. And this is a local password. This is a password that we use to encrypt your data locally. It's very similar to like what Voltage does, or you might have seen this with like other Bitcoin companies where they want to persist some sort of signing key in your browser storage, but they don't want it available for everyone else to be able to access. So by default, it's stored encrypted. And it's kind of annoying to deal with because if you're familiar with React, like anytime the page refreshes and your internal React state refreshes, we'll download the blob, the encrypted blob of your signing device from local storage or wherever, but you have to decrypt it again. And so there's sort of this dance that we've had to learn in React, like how do you keep the state persistent so you don't keep getting kicked out of your signing session. So that was like one challenge that we had to figure out when building this. So anyways, I'm going to go ahead and sign in as, I believe this is Alice here. So we'll log in as Alice. Boom, hit unlock. We're logged in. I'm going to go ahead and just create this draft. So I'm not really going to put anything in. Everything's sort of already pre-filled in. The proposal is pretty much empty. And I'll go over what these different fields are. Right now, it's just empty fields. We have proposal. We have roles. I'll go into what these are, but I'm just going to get started and create this draft. I actually do want to mention this before I move forward. So what we're essentially doing with this proposal is we're building multiple Bitcoin transactions. And this is what's going to be signed by depositors and then handed to us as an escrow agent. And this is essentially all we have to spend. We have no negotiating powers over what gets spent. I think this makes us superior to 2 of 3, because with 2 of 3, essentially, whatever the terms are of spending can be renegotiated. Whereas with what we're doing, we're just given these pre-signed transactions. We literally can't renegotiate anything. All we can do is execute. So yeah, so as you're adding these different spending paths for different conditions, like for example, if I wanted to add a payout, maybe for like 5,000 sats, and then this is pretty cool. Like we made these like cool React components that integrate with your signing device, so you can just pull an address from your signing device. I think that's pretty cool. And then we can just add this path to our contract. And you'll see that we have this payout path is now 15,000 sats, and we have a return path for 10,000 sats. There's actually a bug here because this should be red. You can't set up multiple spending paths that are different amounts, at least not right now. And the reason for that is because we're using anyone can pay for these transactions. And right now with the way things are, like once all the terms are set, there's no way to negotiate a change output for funders of a contract. If you're a member of a contract, then you can, and you know you're going to be funding, and you know the amount that you're going to be funding, then you can just like put a payment in here. Like let's say, oh, I want to deposit 10,000 sats into this, but you know I actually have a UTXO that's 20,000 sats, so I want 10,000 sats back as change. Then you can add a payment output, and that way you can get reimbursed. But otherwise, there's no real way to negotiate change outputs once everything's been signed and endorsed. So that's why for these multiple transactions that we're building, they all need to be the same amount. So anyways, let's keep moving. Let me actually reset this back to default. There we go. And we're going to create a draft. Yeah, so how we're doing this is essentially we're creating a URL that has the entire contract in the URL string. So we're still experimenting with this, but it seems to be like a really easy way to share contracts and have people negotiate it on a peer-to-peer. So for example, if you have a friend that you want to enter a contract with, you can enter your terms into the contract. And we have this thing called roles, where you can kind of set up, okay, if you're the buyer of this contract, then we need these things from you. We need you to create this spending path for this amount. I'll get into what program interfaces are. But essentially, we need these things from you in order for you to fulfill this buyer role. So all I have to do is just kind of click this button to join. And I join as the buyer. You can see a path is created for 10,000 sats. It automatically inserts an address for my signing device. For the return path, because I'm the buyer, and for buyer protection, I might want to be able to dispute a transaction and receive it back. So yeah, all that's set up. So spending path is set up for me. There's going to be a transaction created that makes this payment for me that the escrow agent will hold in escrow. But then there's this thing called programs. And this will start to make more sense once we get into how the virtual machine works. But you can think of our use of smart contracts and VMs like a virtual machine is just, it's just an interpreter that interprets your smart contract language. So think of Bitcoin. Bitcoin has Bitcoin script. Bitcoin script is interpreted by the Bitcoin script interpreter. So what we're doing here is we're trying to build a bridge. I know that's a dirty word nowadays. But we're trying to build a bridge from the consensus layer of Bitcoin to this intermediary layer where you can kind of insert any VM you want that executes any sort of scripting language you want. So right now we have this just bare bones basic scripting engine that we called CVM for Contract Virtual Machine. But the idea behind these interfaces is that we're more interested in building a cryptographic proof so that we can verify the execution of the contract. And so this interface sort of represents how do we interface with this virtual machine? What are the conditions? What can we do? What actions can we take? What methods can we call? We have this thing called paths. These are the spending paths. This is how the VM refers to which transaction should be spent. And then we can also just do like signatures with a threshold because when you interact with the VM, everything's done through signed statements, so everything's cryptographically signed. And we can institute a threshold here of how many signatures we need for a particular interface to be interacted with. So you can set all this up. Right now what we have set up is we can take this close action in the VM. What this does is essentially closes the VM, it settles the contract, and we're using regex right now for some of this stuff. It's not the sexiest thing. Grandma doesn't know what regex is. But it is very convenient to use because like you might have one path that you want to allow, you might have multiple paths you want to allow, you might want to allow all paths. And one thing that I've experienced is that when you're freeform writing these contracts, it's very easy to express your intent with regex. Than it is to have to like drop down and select this, that, and the other thing, kind of build that out. We'll have a better interface where you can do that anyways, where it's just all forms and you don't have to do any fancy developer stuff. But right now we're kind of sticking with the regex thing. But yeah, so you can specify, all right, so if we satisfy this interface, it's going to take 2 keys. And with these 2 keys, we can close the contract and we can close it on any spending path that we want. We also have this other interface for disputes. So what this says is that basically either one of us can dispute any path. And that sort of like puts a lock on a path so another person can't spend that path. So we can kind of like do this thing within the VM where we're locking paths, releasing paths, disputing paths. We can kind of do this stuff. You can think of it like with Bitcoin script, there's really only one condition, and that is spend transaction. It's like the only action you can take, spend transaction. But with this VM, we actually have different actions you can take because we're dealing with different transactions that are sort of in escrow. So yeah, so we have these 2 interfaces, and as the buyer, we have our keys listed here for these 2 interfaces so we can interact with them. And this is pretty much set up the way that it needs to be. So what I'm going to go ahead and do is I'm going to share this contract. So when I click this button, it'll copy this link to my clipboard. And then I can just go ahead and paste it. And when I paste it, basically see the same screen. I see all the same information because everything's in this link. So it just gets downloaded back into the interface. And so now I can be somebody else. So I'm going to go ahead and be Bob here. I'm just going to log in as Bob. Boom, unlock, and I'm going to join as the seller. And so I click this button. It's going to add the necessary information here for spending paths. It's also going to insert Bob's pub key here for these interfaces. So now we have the keys that we need for these interfaces. And so far, so good. But we still need an agent to be able to handle disputes. Yeah, a quick aside, BitEscrow, on a protocol level, we do not do arbitration, period, and stop. The whole idea of this contract system is that it's fully deterministic and it's fully transparent and fully auditable. And you can't do that if you're an arbiter. So that's one criticism I have with other escrow services is that they do escrow and arbitration, where we're just doing escrow. That's what we focus on. Okay, so let's go ahead and share this link to whoever our third-party arbiter is going to be, which will be Carol. Carol doesn't get used very much, but I believe this is Carol. Yeah, it's usually just Alice and Bob, but you know you screwed up when you got to get Carol involved. Okay, so Carol's going to go ahead and join as an agent. And so there'll be an additional program that Carol inserts in here, or her signing device does. That is the resolve action. So we inserted this because you might want to prevent a particular individual from closing a contract, but you do want them to be able to close it in the event of a dispute. So it sort of gates Carol where she can't arbitrarily close the contract, but she can be called upon to close the contract through this resolve action. So again, this is just something that we came up with our CVM, but you can institute any kind of logic that you want. So we'll go ahead and endorse this. So in addition to inserting the information, we can add a signature to this to show that we endorse this. And a quicker method here is copy and paste, so I'm just going to use that to go back and forth. So we'll paste this here. All this information just automatically downloaded, which I think is beautiful. We hit endorse, copy, go over here, same deal, paste. I've gotten really fast with this. Now there is a bug in this somewhere where for some reason when I get to Alice, it actually wipes the signatures. So what I have to do, and hopefully this still works, it's worked for me before, if I just go back through this and do this one more time, then it should work. Paste. So Carol's going to endorse again, and now we can publish. So endorsing a contract is optional. You don't have to endorse a contract. As the contract service provider, we don't care who endorses it. It's none of our business. However, I will say that if you do endorse the contract, we will store that signature, we will validate that signature, we'll make it available to other people that are looking at the contract. Maybe you want to see that certain pub keys have endorsed the contract. Also, it does help us with indexing. So without an endorsement, if you come to us and say, hey, can you show me all contracts that are associated to my pub key? We're going to have a hard time doing that because we don't collect any metadata at all. We only collect what you give us. So we're going to go ahead and publish this. Let's go connect to the internet. Yeah, we're good. And there we go. So now this is officially on our platform. This is the point in which we enter this protocol. So we're a contract service provider. What we're getting is essentially a completed contract, already filled out, and from our position, we either accept it or reject it. Like, we can't renegotiate this, we can't change anything about this. So this is what a contract looks like, I guess. We can go through these like different details. Yeah, so every time you have an interaction with the escrow server, we sign what we give you. And the idea is that as you negotiate with us, if we try to screw you at any time, you will have cryptographic proof that we deviated from what we're supposed to be doing. And I'll get into more detail about that. Yeah, so here's all the endorsements from the different members, some information about the VM, which the VM has not started yet because we haven't funded the contract. Yeah, so actually this is still pretty bare. We need to get some funds in here. But I did want to show this. So these are, so far, these are what the transactions look like. They're very small because there's no inputs. So right now, I call these transaction templates. They're essentially a Bitcoin transaction that's all outputs, no inputs. But we'll be adding the inputs with funding. So let's go ahead and make a deposit into this contract, and I'll take you to the deposit page. And same deal, we can kind of click this button and magically have our address entered in here. So when you make a deposit, it's going to be a 2 of 2. And it's going to be a 2 of 2 with a time-locked refund path. And so this is to ensure that if you deposit funds into this deposit account and then we just cut you off and we stop talking to you or we have some disagreement, all you have to do is wait out the time lock and then you can just sweep your funds back. So that's what that's for. Otherwise, it sits in a 2 of 2, and we have no way of spending the money until you give us the pre-signed transactions. So we have the pretty standard stuff. We have this little slider, which actually doesn't really work the way you would think, because testnet, all the testnets don't have like proper fee estimation. So it's always going to be 1 sat per vbyte, for now anyway. And yeah, so we can see some information about the contract here. So we're going to go ahead and reserve an account. So in order to set up a deposit, we need to collect, as the funder, we need to collect some information in order to do the 2 of 2 musig. So that's what we receive when we create an account. Essentially, we're going to get this little packet of information. I actually don't know if I have it set up so you can see what's inside of this, what an account looks like. So that's something that we should add, because it's pretty interesting, like the information that we have to put in a JSON object for an account, just to set up this 2 of 2 musig. So anyways, one of the things with deposits that we really like, and that I tried really hard to preserve this, is the ability to just scan a QR code. I feel like if you can't do this very basic thing, nobody's going to use your protocol. It needs to be really easy to get into. And so the way that we design deposits is so that you're basically presented with this, and then you can scan it and just send money. But you can also just copy the address here. And we're going to use Mutiny to send money into this. So another thing I want to mention is that, so right now, in order to satisfy this contract, we need to deposit 10,100 sats. So we'll go ahead and do that. Copy address. Open the faucet. By the way, if you're not using Mutiny, you should be, because Mutiny is the best when it comes to testing stuff on Bitcoin. All right, so we funded that. It's going to register the deposit, and it's done. So we can view the contract. We can view the deposit. Let's view the deposit real quick. So essentially, this is the deposit. Right now, I think we do have the covenant set up. We're calling it a covenant. It's pre-signed transactions, so we're sort of emulating a covenant using pre-signed transactions and a 2 of 2. It's similar to what Lightning does. So these are the partial signatures. We have one partial signature for the payout path. We have one partial signature for the return path. So as the escrow agent, we can complete any one of these signatures to spend that transaction. But there's actually one additional thing that's happening here, which I'll go into more during the slideshow. We're actually tweaking these signatures with the terms of the contract. And one cool thing about that is just because of the way multisig, but I think more specifically the way musig works, although you could probably do this with traditional bare multisig, is that whoever leads the signing round, so if it's a 2 of 2 and I as the funder, I'm stepping in, I'm giving you my partial signature, I dictate the terms of that musig. So I dictate what, essentially if you've given me a nonce, I can tweak your nonce, and then if you want to use my partial signature, you're forced to tweak your nonce in response in order for my signature to be valid with yours. So doing this, the funder can essentially come in and say, hey, I like this contract, here's these pre-signed transactions, they fit this contract, I've tweaked each of the signatures so that they attest cryptographically to this contract, you can't do anything about it. So if we want to spend any of these transactions, we have to agree to the terms of the contract cryptographically. So that's how we set up the essentially the optimistic, transparent validation of everything that we're doing. Okay, so that's a deposit. Let's go ahead and look at a contract. Here we go. So this has been paid, and there's this thing where it doesn't update unless you refresh it, and then the contract should be active. So now this contract is, the VM is running. You can see that it has an expiration. So all contracts have to have an expiration for now because all deposits can expire. In order to safely deposit funds as easily as we have it now, where you just scan a QR code and deposit funds, we have to have that time-locked refund path, and that time-locked refund path means that we can't guarantee these funds once that time lock expires. So that kind of puts an expiration date on your deposit. We are going to be doing like a version 2 of deposits where that's not the case, but that's like a future announcement. So yeah, so this VM's running, it's fully funded, we have this contract. So one thing I wish that we had ready for this is to show you what's going on within the VM. So one thing I can do is I can look up the the ID of the VM, because we do give you this information. I just don't have like a good place to show it to you visually. So if we take this, actually no, it would be HTTPS. Oops. Let me see if I have it in my history. Yeah, we do have it. Okay. So that's one endpoint. That's for us doing key rotation because everything is signed. But if we throw this in here and we do API, VM, VM, and that. So that will just show the JSON view of the VM. So again, it's really simple. It's nothing fancy. It's really just an interpreter that's interpreting the contract and the statements that we're going to be feeding into it. This is the state. All it really does is just, it has this sort of it has an enum state for each of the spending paths, and it tallies inputs. So you feed it inputs, it tallies those inputs, it changes the state of one of the spending paths, and if one of those spending paths basically closes the contract, then the contract closes and we spend on that output. So that's all it really does. It's very simple. And that's what we're going to do. We're going to start feeding it statements. So we have a little form here, field here for feeding it statements. So we're going to go ahead and just really quick close this contract. We're going to use the endorse method, which is just a digital signature. We're going to close the contract on payout. Thank you, Bob, for the widget. We'll close it, submit. Oops. Oh, so matching program not found because I'm doing this as the agent. So the agent can't close the contract. It has to be Alice and Bob. Okay, so let me jump in here as Alice. And thank you, Bob, for the widget. Okay, hit submit. Boom. So now we have this statement here. We can actually look at it in the non-pretty version. All it is this statement. Basically, you have an arguments field, so you can feed arguments into the virtual machine if the method you're calling accepts those arguments. Similar to JSON RPC, you call a method with arguments. You can also specify an action that the virtual machine can take. And another thing I want to bring up is like you can actually have multiple signatures with a statement. So if you want a statement that requires 2 signatures or 3 and you want to just send it all, just one statement with 3 signatures, you can do that. There's the ID of the virtual machine. This is a cryptographic proof that attests to the information in the virtual machine and the contract. Also, the witness ID. These are all essentially cryptographic attestations. And then there's the virtual machine hash. And I'll get into this, but essentially every time you add a statement to the virtual machine, there's actually a hash chain that's running behind the scenes. And so we start that hash chain with the virtual machine ID, and then every time you add a witness statement, it updates that hash chain. So it kind of is this attestation of not only the statements that you're inputting in, but the order that they're in, similar to what you all know and love, the blockchain. Very similar concept. So anyways, we're going to go ahead and close this as Bob. So I believe Bob's over here. And we'll click here. We'll close this contract. We have a cool little timer here going. By the way, not a single line of CSS was written for this demo. This is all mainlined Mantine components. Yeah. So all right. So we'll close on this path. Thank you, Alice. We'll submit. Boom. So that closed the contract. It's already broadcasting the final transaction. You can see this little chain here. There's this statement, and then there was this statement. We have a long ways to go to better present this information so that grandma isn't completely confused and beside herself looking at this. But yeah, I think as a developer tool, this has been really nice to use. It's really helped me just like discover all the cool little bugs and edge cases that have been hiding from me. But yeah, so we're going to go ahead and click this just to look at the final transaction. So this is on MutinyNet. This is all it is. So because we're using Musig, like none of the information that's in the contract ever goes on chain. There's really nothing that goes on chain. It's just a single signature, and you can't tell who did what. So that's how we have the complete privacy. You really can't tell what happened here. However, it's not zero knowledge, so if there is fraud and you want to prove fraud, then you do have to have this information. You essentially have to have the contract and you have to have the witness statements. So if we have any time, this is pretty much done. We're done with the demo. In fact, I think if I refresh this, it'll say that it's settled. That's MutinyNet for you, every 30 seconds. Yeah, we can even look at the transaction here. That's what it looks like. It's really simple. So yeah, so that's the BitEscrow demo. I don't know if I have time to go into the slideshow. I think we're all running behind today. Okay, well, yeah, screw it. I want you guys to get to lunch, so let's just do the Q&A.
Yeah.
Yes.
And then the other question was more from the user perspective. When you're depositing money into the contract in the first place, presumably they're just using a new wallet.
Yes.
And they're creating an on-chain transaction.
They are creating an on-chain transaction to deposit, yes.
Yeah. And then when that deposit expires, you said something about they have to sweep the funds. They're not automatically sent back to the same address?
So there's two things there. So there's two ways we can do that. We can collaboratively close the deposit. It's very similar to Lightning. Or they can execute they can sweep it by doing the script path spend. So when you make a deposit, part of that negotiation is that you pre-sign that the refund transaction, similar to Lightning, so that when your deposit expires, we can collaboratively close it for you, so that your money just isn't locked up in the wild. Just in case like you lose everything and you can't recover anything, then you can do that. But we also, I haven't implemented it yet, but we also want to store at least the transaction hex of doing the script path. So we have that available as well. And a lot of thought has been put into making it like just going over all the worst case scenarios that if you did lose everything and you had to reconstruct the transaction for doing the script path spend, all you really need is you need to know the return address that you used, and you need to know the two keys that were used in the MUSIG. So those are the three key pieces of information that you need. One of those, both of those can be deterministic from the funder side, like whatever deposit key you use and whatever return address you use. And then the key that we generate for that MUSIG is also deterministic. So assuming we're cooperative with you, if you give us those two pieces of information, we can actually recover the key that we used for that MUSIG. So yeah, those are all the options.
Yeah, I'm just trying to think from like the most basic UX possible. You don't want to have that, hey, you're having to do too much upfront.
Oh yeah, no. Yeah.
So I can imagine the simplest thing is to supply an address as the return address.
Mm-hmm.
Just have it automatically deposit back to them if the deposit expires. Which is already a lot to do when you're paying for something you just want to pay for it.
Mm-hmm.
Yeah.
Yeah.
Maybe you could skip registering another address and just send it back to that same.
Yeah, so you have to remember this is just a developer playground. Once we start the app development for grandma, all of that stuff will be super, super easy to use for everybody, right? Whether it be your grandma or like a 10-year-old using Fortnite to bet their Bitcoin for a match. But go ahead, Topher.
Yeah, so I also wanted to say, so version 2, we're going to have like a V2 version of deposits, which is going to require a little more onboarding because we need to know the UTXO beforehand. But it allows us to basically get rid of the time restriction. It also allows us to renegotiate change, so we can do splicing, essentially. And another thing that it allows us to do is what we really want to do is we want the optimistic happy path of your contract is not that the Bitcoin gets spent. It's that the contract is satisfied and we release the lock on your funds. And so the idea is that you lock up this Bitcoin as collateral, you create a contract around it, and that contract receives some payment in some other form. And if that payment is satisfied, then we release the lock on the funds, and then you can reuse that in another contract ad infinity. So yeah, so that's kind of what we're going for. You can sort of do this now. So if we release the lock on your deposit, you can still use it. So if you have a really long time lock on your deposit, as long as that time lock doesn't expire, then we can we can safely use your deposit in a contract. But ideally, we do want to get rid of that, and we want this to be something where you don't spend Bitcoin per se, but you essentially manage Bitcoin that you have in escrow or as collateral for these sort of escrow contracts.
But for that world to be possible, we're going to need wallet integrations that can serve those addresses as well.
For the version 2. For V1, you can do this now. We're just restricted by the time lock. Yeah. But because every time a funder signs transactions, because those signatures are tweaked with the contract terms, and just because we're already doing escrow in the sort of optimistic system that we have set up, we don't need revocation. So there's no like fancy cryptographic negotiation that we have to do to revoke old transactions. We just simply get rid of them and don't spend them. And so it's very easy for us to receive a covenant from a funder that locks funds to a particular contract and then just delete it and just rinse repeat. Yeah.
Any more questions? Cool. All right, well, I hope you guys liked it, and be sure to check out our new website at bitescrow.app. Thank you.